memory, or magnetic data storage, is a key component in computer operation. This depends on the ability of magnets to magnetize other materials and the ability of those materials to retain their magnetization until forced to change again by exposure to another magnetic field. Furthermore, an object can be magnetized with the north or south pole at either end. You may already know that data is stored in computers in a series of ones and zeros, a machine language more commonly known as binary code. But how can we represent a 1 and a 0 magnetically? Let's take a look.
A bit is the smallest unit of data storage. It can be visualized as a minuscule block that can be magnetized into a permanent magnet. Every red, blue, or gray block in this picture is a bit. The red blocks have north poles facing up, and the blue blocks have north poles facing down. These are what the computer recognizes as ones and zeros. Gray blocks are the empty bits that have not yet been magnetized. The right head is basically an electromagnet with a core appropriately shaped like this to direct the magnetic field into a bit and magnetize it as it passes by. It can magnetize a bit as a north facing up or a north facing down, simply by changing the direction of the current in the coil. As you may remember from the earlier sections, reversing the direction of current in an electromagnet results in reversing the direction of the magnetic field. Once written, the bits can be read by the read head, which senses the direction of the magnetic field as it goes over a written bit. A hard drive as a whole looks like this. Both the read head and write head are at the tip of the actuator arm. The motor of the disk and the motor of the actuator arm work collaboratively to align a desired bit with the read head or the write head at any given time to read it or write it.
A few years ago, an iPod of this size had the capacity of about 1 gigabyte. But now, a similarly sized iPod has the capacity of about 160 gigabytes. With each passing day, capacity just keeps growing more and more. But have you ever wondered how they can increase the capacity so many times without increasing the size? Let's take a closer look. As we have already seen, magnetics are an essential component to data storage. Research has led to additional applications such as magnetic logic, which will provide more efficient and effective ways of manipulating and storing data. Currently, computers are composed of 3 major sections: processors that control operations and manipulating data, random access memory chips, or RAM, which act as temporary data storage, and the magnetic disk drives that retain information even after power is turned off. Although computers are very complex, they're based on a combination of simple circuits called logic gates. A logic gate is a device that produces a specific output for a given input. There are several different types of logic gates. For example, a type of gate called an AND could be represented by a circuit with 2 switches and a light bulb which only lights up if the first and the second switch are on. If you were to replace the light bulb with a switch controlling the input to another gate, you would have the basis for a more complex system of interconnected gates. In today's computers, logic gates are built from electronic transistors. However, they can be built using many other materials. There are mechanical logic gates based on gears, electromechanical systems based on relays, and even ones based on individual molecules. A critical quality of any logic system is its speed. How quickly does a change in input result in a change in output? Magnetic logic systems can be very fast, and they have an advantage over transistor-based systems. They retain their information even after power is turned off.